Welcome to another tutorial video about Impulse nVision. Today we will talk about extended visualization in the development environment. The output window of a subpipeline usually displays the data that is connected to the first output port. For example, this is connected through the input image. However, sometimes a different, easy-to-understand, and clear visualization of the results is needed, or a specific, intuitive, and easily operated user interface. For these purposes, nVision offers a flexible and powerful set of tools, the widgets. Widgets are nodes that create and describe visual elements. An example is probably the best way to show how to work with widgets. Let us begin with pipeline of the last video. We inspected parts and classified them into two categories, I/O for OK and NIO for not OK. The output window only shows the input image, without any information about the class. We want to make notice if the part is OK or not OK by showing the text I/O or NIO within the window, depending on the result of the classification. We need widgets for this. Working with widgets always starts with an instance of the display widget, which is superior to all others. You find it with right-click, Widgets, Display. As soon as the display widget has been created, the output window no longer shows the contents of the output port, but the widget visualization. This is currently empty, with a white background. The display widget node is shown in the pipeline editor window in green color. Widgets have connectors at their left side that are used to set their properties. The display node has one property, background, which is the background color. Let us change the background color to a bright blue, using a brush node with the right-click, Widgets, Create Brush. Let's create a bright blue that we can check directly in the node and connect the output with the background input of the display widget. This way the output window gets a bright blue background. You can see 4 small connectors at the bottom side of the display widget node. This can be used to connect other widgets. Let us quickly think about what we want to display. We want to see the input image, and on top of the input image we want to see some text. We create an image widget node with right-click, Widgets, Image. The image widget node looks similar than the display widget node, with the difference that it has one connector at the upper side, and we can use this connector to layer an image on top of the display to show it in the output window. The image itself is specified with the image input. Let us connect our input image with the image input. By changing alpha, we could change the image opacity, but we want to leave its default value of 1 for now. The text is still missing. The classify subpipeline already produces the correct text. To show the text, we use a text widget. Right-click, Widgets, Text. The text should appear on top of the image, so we connect the upper connection with the image widget. The text appears relatively small. We can change this with the font property. In order to do so, let us create a font node with the right-click, Widgets, Create Font. Using this font node, we can change the size of the text. One recognizes that widgets are arranged in a hierarchy, or tree structure. Subordinate widgets are called child widget. Superordinate widgets are called parent widget. This structure is important when transformations are used. Child widgets follow the transformations of their parents. For example, if you would like to scale down the image, the appearance of the text would follow. You could also connect the text widget node directly with the display widget node in order to avoid that. Let us connect the output of the classify pipeline with the text input of the text widget. Now, with error-free parts, the text I/O will be shown, and NIO with faulty parts. We would like to distinguish the two classes by using different colors, and therefore, we go back to the classify subpipeline. We select the text with binary selector node. In the same way, we can distinguish between two colors, that is, two brush elements. Let us create a red and a green brush with right-click, Widgets, Create Brush. Here we select the color green. In the second brush, we select the color red. Now we need another binary selector node with right-click, Core, Logic, Binary Selector. The selector input will again be connected to the output of the compare node. If the case is true, the part is OK, and we want to see the text in green color. If the case is false, the part is not OK, and we want to see the text in red color. Now the chosen brush needs to be made available outside of this pipeline. For this purpose, we create a second output port with right-click, Add Output Port. We can name this output port with Text Brush. If we go back to the superordinate pipeline, we now see the second output named Text Brush at the classify pipeline. Let's connect it with the Text Brush input of the text widget node. The text color is now bound to the class of the image, and we can show the parts together with their classification results. Thank you very much for your attention, and I'd like to encourage you to try out nVision. See you soon.